Good morning, guys. Welcome to the class of CE3C1, Environmental Engineering 1. So, in the last class, we were discussing on-site and off-site sanitary system and dry system and wet system. We also discussed the dry system and wet system. And the thing is permeable and confined system. So, what was on-site system? Just to get a review of that. In your on-site system, wastes are collected, treated, and disposed at the point of generation. For example, pit latrines, septic tanks, widely used in rural areas, both developed and developing countries. Okay, so on-site system is the system. For example, if I give a pit means a hole in the soil. So if you have a hole in the soil, you collect your waste material over here, and then you, when it is filled up, for example, after several years, then you close it down, and the soil is the waste matter is degraded, biodegraded by the soil, and then it, after few months, it becomes completely soil, so you can dig them up again and use it. Okay, anyway, so what I was telling here, that in this case on-site system, the waste is generated here and also treated here at the same location. So that's waste are collected, treated, and disposed at the point of generation. This is called on-site system. And one of the example is like this pit latrine. What is off-site system? In off-site system, for example, waste is generated here. For example, in Dhaka city, what we see majority of the cases that waste are generated here and transported through a sewer pipe to somewhere else at the water treatment plant and then discharged. So here what happens, that waste is generated here, but it is transported to somewhere else and treated here at a different location. This is we call off-site sanitary system. Okay, for this system you need a pipe network. Okay, so therefore this is costly. So this is only viable method where you have where you have densely populated area, where you have densely populated area. For example, lots of buildings closely located. In that case, and of course they are developed country. I mean, our community, they have good income. Then you can provide this off-site sanitary system to this location. Sphere, right? Okay, but where you have a you have a locality where it's a rural area. One house is here, another house is here, so it's sparsely located here and there. There you should go give this one because this will be cheaper here. Okay, the principles of on-site system and off-site system, this is important. Here in on-site system, infiltration of liquids into the soil is allowed. That means here infiltration of the waste through the soil is allowed. Solids are retained, digested aerobically, and have to be removed, or a new pit has to be dug at regular intervals. It is primarily designed to dispose human excreta, human solid waste. Wastewater from cooking, clothes, washing baths are collected in small drains and disposed of in soapways for infiltration. If guys, are you following me?
Yes, sir.
If the water is from cooking, clothing, clothing washes, and bathing, so these are less polluted water. These are not as polluted as this one. So in this case, these waters, what we do is we in the soil we make a trench here. Soil, you make a channel in the soil by digging, and you make different pores here. So what happens when the wastewater from these sources, cooking, clothing, comes here, they are transported through the soil, and since there is pore, the water gets infiltrated and they are digested in the soil. This is for the less polluted water coming from cooking, clothing, washing, and bathing. Okay, so this is called soak away, soak away, soak away for infiltration. This system is most suitable, the on-site sanitary system is most suitable for a sparsely settled. That means sparsely means at a big distance from one another. Like I say it here, sparsely settled here, sparsely settled rural areas with low population density. So the population density is very low here, okay, and low water consumption because of the system's dependence on the infiltration capacity of the soil for the disposal of the liquid portion of the excreta. So, since this system is dependent on the infiltration capacity of the soil, in this case, the wastewater has to be infiltrated to the soil. So, you need a particular, I mean, you need a sufficient amount of land, okay, for the wastewater to be infiltrated. If this is densely populated, then you may not be able to apply this. Offsite sanitation system, which one is this one? This one is the offsite sanitation system. This one. In Dhaka city, majority of the cases we see this sanitary sewer system, offsite sanitary sewer system. So waste is collected and transported to somewhere else for treatment and disposal. So down somewhere else. Bucket catering system or conventional sewerage system. This is the conventional sewerage system using a sewer or pipe to transport the water. Sometimes it's also possible that you collect it in a container or a bucket and then transport it to somewhere else for the treatment. For the treatment. Is it clear, guys?
Yes, sir.
Yes, sir.
So the basic element of this system are collection, transportation. Of course, you have to collect it here first, collection, and then transportation, and then treatment, and then disposal, and then treatment, and then disposal. Okay, so sewers, I already told you, or manual using bucket. So if you transport it using a sewer, so you're using water. You're using water. So this is wet. It can be wet system. But if you're collecting it to a container or a bucket, so this is a dry system. So offsite wet system, offsite dry system. Okay. Similarly here, in on-site, if you use water here, it can be on-site wet system. If you don't use water, then on-site dry system. Okay, provided sufficient funds are available in offsite sanitary sewer system, sanitary here offsite, you need to have to install this sewer. You need money. It's expensive. Therefore, sufficient funds need to be available to install these kinds of facilities. Dry system, wet system, I already told you. Dry system, no water is used for dilution of the waste. In wet system, waste is diluted with flushes of water. Okay. Now, what is permeable and confined system? Look at here. Here, the wastes are collected in this soil and permitted to infiltrate. The wastewater is permitted to infiltrate. So this is permeable. Why? Because the wastewater is permitted to infiltrate through the soil here, right? This is permeable. What is impermeable? In sanitary sewer system, you always have a septic tank here. And this septic tank is made of concrete and water is stored, wastewater is stored here and not allowed to infiltrate in the soil. This is concrete. Wastewater is not allowed to infiltrate in the soil. So this is impermeable system. Impermeable and permeable. Permeable is water is allowed to infiltrate. Impermeable means the water is not allowed to infiltrate. Clear?
Yes, sir.
Like septic tank. On this impermeable sometimes can also called confined. Impermeable or confined because they are confined. We have confined it, so water cannot pass through. Confined, and another is permeable or unconfined. Okay? Liquid part is allowed to infiltrate. It may cause potential. It has the potential to pollute groundwater. In this case, since you are allowing the water to pass through the soil, so if you have groundwater here, it may pollute the groundwater. Of course, there are some design considerations you need to take so that it doesn't happen, but there is a risk. So permeable and confined sanitary sewer system. What I was trying to say here is that since you're allowing the pollutant wastewater to infiltrate through the soil, so it has the potential to pollute the groundwater. But here you are not allowing the water to pass through, so it cannot pollute the groundwater. Is it clear, guys?
Yes, sir.
Yes, sir.
Okay, so criteria for good sanitation system, you should go through this. It should be simple, inexpensive, should not contaminate the surface soils, should not contaminate the surface soil or surface water or groundwater. Minimum handling of excreta and free from odor and unsightly condition. No access to flies, insects, and animals. If you allow insects to go there, then these insects will be the potential vector to transmit disease. So this system must not allow the insects or flies to go inside of this. No access to flies, right? Should or insects or animals should use little or no water. Should require little or no water. Should require little supervision and maintenance. Should handle all waste and wastewater. Should use little or no mechanical equipment. I'd like to mention here one thing. Yeah, I already explained it, right? Yeah, fine. So water safety has been difficult to meet so far in worldwide. Okay, a majority, a significant proportion of the population, or population, is still lacking from safe water. So UNDP is working on this, and SDG, as I told you, SDG number 6 is directly related to WASH, WASH, which is basically water, sanitation, and hygiene. Commitment to progress. So as you can see, Sustainable Development Goals (SDGs) target to water, sanitation, and hygiene (WASH). These are basically 6.1. These six also has 6.1, 6.2, so subheadings, okay, or sub goals. So under 6.6, there is 6.1, 6.2, 6.3, 6A, and 6B. And also the other goals like goal number 3, 3.9, these also are directly related to us. Okay, go through this. Okay. Having said that, that's the end of this topic for our sanitation and health. Now we'll move towards the water quality and treatment. Water quality and treatment. How do you determine if this water, if a particular water is good quality or poor quality? Good quality or poor quality? How do you determine this? There are certain parameters in water. There are certain parameters in water. By measuring them, if they exceed a certain standard value or does not exceed a standard value, based on that, you can tell the water is good for a particular purpose, whether it's drinking or for any other industrial purpose. So these parameters may be pollutants or any other thing. If you talk about the pollutant means which pollutes the water. If you talk about the pollutants, we need to know what are the pollutants and their classification so that we can easily identify whether this water sample is good or poor. Is it clear?
Yes, sir.
So what are the classifications? So classification of impurities. That means the pollutants. You can call it impurity. Okay, impurity. So impurities in water may be classified according to the sources of origin and form of presence. How can you classify it? First of all, you can classify it by the sources of origin. Also, you can classify it based on the form of presence. So starting from the sources of origin, if the pollutant is inorganic, for example, what is organic by the way? Organic is what? Which has carbon and hydrogen chain, long carbon hydrogen chain. That is organic, right? Any kind of
Yes,
food,
sir.
our body is organic, our flesh, skin, these are carbon, hydrogen, nitrogen, right? So long chain. The food we take, that is organic. The plants are organic. Now, what is inorganic, which does not have this? For example, sodium, iron. Impurities can be pollutants, right? This can be organic. This can be inorganic. There are others. I'll come back there. So organic, as I told you, that has long carbon, 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 this chain, right? And many others. So the thing is, the examples are oil, right? Then any synthetic organic matter that has this carbon hydrogen chain, any food, anything, okay? Anything that has this carbon hydrogen chain. What is inorganic? Which does not have this carbon hydrogen chain. For example, as I was telling, sodium, iron, then what else, guys? Sodium, iron, then there are thousands, chromium, lead, arsenic, right? Fluoride, sulfate. I can name thousands. It's not thousand, at least 100. So, so inorganic or mineral. So we call it mineral. This is a mineral. Sodium, iron, these are minerals, right? Sodium, iron, that's a mineral. Iron plus 2, it's a mineral. Iron plus 3, that's a mineral. Ferrous, right? So that's inorganic and organic. Living impurities. Living in, what is that? Living. What is that? Tell me. Hmm? Living impurities. What is this? Hmm?
Bacteria, sir.
Bacteria, virus, and others, right? Living impurities. And then the radioactive impurities. There is a special categories of impurities. Radioactive, which can radiate. Radioactive, right? Can cause cancer. This can also cause cancer. Chromium, lead, arsenic. This can also cause cancer. Radioactive for uranium. Uranium. This can cause cancer. Radioactive. This is, that Here the atom breaks down and radiates, right? And this radiation may cause cancer. So that's why they have been categorized into another category, classification, radioactive. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
So that's the classification based on the sources of origin, based on the sources or type of origin, source or types of origin. It can be classified as based on the sources of origin, it can be organic, inorganic, living, radioactive. Now, if we divide or classify them based on the form of presence, physical presence, that will be suspended, colloidal, dissolved, three basically suspended, colloidal, and dissolved. Suspension, what does this mean? Suspension. Suspension means when the pollutant size is greater than 1 micrometer, greater than 1 micrometer. For example, sealed clay. So these pollutants, right? If their size is greater than 1 micrometer, we call it they are in suspension. For example, sealed clay. Okay. One of the criteria of this suspension is that you can easily filter them out. You can easily, if you filter it in a with a screen with proper filter size, you can screen them out. You can filter them out. Okay. If you filter them, then these pollutants will be removed. Easy. In colloidal suspension, what is colloidal suspension? When this the size of these pollutants is this less than or not less than 1 to 1 into 10 to the power minus 3 micrometer, 1 to 1 into 10 to the minus 3 micrometer. That means these are much smaller. Then we call it um, colloidal suspension. Okay. For example, bacteria, virus. It's very difficult to remove them using filter. Okay, bacteria, virus are in this range. Decomposable organic matter. In solution. Now, what is in solution? In solution means the particle is those are even less than 10 to the power minus 3 micrometers. For example, when you have iron dissolved in water, clear? When you have manganese dissolved in water, so these are dissolved, these are in ion form. These are so small, less than 1 into 10 to the minus 3 micrometer. Okay, very small. Is it clear?
Yes,
Yes,
sir.
sir.
And they have given examples like inorganic minerals like dissociated cation and anion. Dissociated cation, this is cation. Dissociated means dissolved basically. Dissociated cation. What is anion? That may be sulfate, anion, chloride. These are anions, right? And this is cation. Okay. So this table is important to know that to know the different types of sorry from here different types of pollutants and their classification. Okay, it can be inorganic, it can be organic, it can be living, it can be suspension. So suspension can also be inorganic suspension, organic suspension, living suspension. Then inorganic colloid, organic colloid, living colloid. Then inorganic solution, organic solution, living solution. So there can be different of different types.
স্যার
Clear?
পলিউটেন্ট আর ইমপিউরিটিস একই কথা?
Same thing. Yeah, I already told it.
ওকে স্যার।
I already told it here. Pollutant is the same thing as impurity. Okay. Let's see what are the sources of water. Absolute pure water is not found in nature. Basically, you don't need absolutely pure water. It's not good for your health. I mean, that's not desirable actually. Absolute pure means what? Absolute pure means only H2O. There's only H2 or nothing else in this. This is distilled water basically. This is distilled water. You use this for making batteries or in the radiator of your car and many other there are a multitude of usage of distilled water in laboratory, but in drinking water you should have H2O alongside with sodium, potassium, these minerals which is healthy, I mean which is good for your body. Of course, within the limit, they should not exceed the limit. They should not be in such a high amount that is harmful for your health. If they, you need them in your water, but at a desirable limit. These minerals, we call it minerals, okay? Sodium, potassium. Absolute pure water is not always desired, as I told you. As condensed waterfalls, it's okay. Now surface water and groundwater. Surface water is what? Surface water, that water is in directly contact with atmosphere, like pond, lake, river, canals. And groundwater is what? Which is under the soil, beneath the soil, right? Like you can get them from tube well, dark well, or spring. Now, two important I mean, some distinctive difference between surface water and groundwater is, in case of surface water, what happens? You have mountains here or uphill. When you have precipitation, when you have precipitation from here, rainfall or snowfall, this water flows towards a river or canals, right? So what happens that they are directly in contact with the sand, right? Sand particles or silts. So they easily bring this sand and silt into the river. Surface water, therefore, surface water has huge abundance of silt and clay. Am I right?
Yes, sir.
জি স্যার।
But in case of groundwater, there is groundwater soil. In case of groundwater, When there is rainfall, this rainfall percolates through the soil, percolates through the soil, and you have what soil particle, right? And this water particle has to pass through the pores of these soil particles. If you have sand particle here, for example, you have sand particle this, right? You have sand particles here, and you have soil particle here. What will happen? This water particle will pass through, but this sand particle will be stuck here, right? So the water is getting filtrated. The water is getting filtrated. So this sand and silt will not be able to come to the will not be able to come to the groundwater. Am I right?
Yes, sir.
Yes, sir.
So due to this filtration, the groundwater is usually silt and sand free. This will not be present here, but here there will be silt and sand. But there is a but. But you have in soil, you have what? You have many minerals. You have many minerals. For example, you have in soil, you have calcium sulfate, solid particle, calcium sulfate. Now, when this water passes through the soil, percolates to the soil, or infiltrates to the soil, this calcium sulfate comes in contact with the water, and calcium gets dissolved into the water and brings up it here, calcium. Since this is calcium dissolved, filtration cannot stop them from reaching the groundwater. So you will get calcium, iron, okay, calcium, iron, manganese. You'll get this in groundwater, but in surface water, usually you may not get these minerals. Clear?
Yes, sir.
Yes, sir.
You may not get this manganese or iron here, unless otherwise they have been discharged by an industry or source. Usually they are not found in surface water, but in surface water you will find silt and sand. In case of groundwater, you may not find silt and sand, but you may find manganese, iron, calcium, based on the of course based on the geological formation of that topography of that particular area. Okay. So now let's see what they're talking about here. During running over the surface, sealed surface water. During running over the surface, sealed clay and other suspended material and bacteria, virus, other organisms mixed with water. Yeah, sealed sand, bacteria, virus. In groundwater, since water is an almost universal solvent, during percolation through the various strata of the soil, it dissolves various minerals, as I told you, calcium, iron, manganese. However, most of the physical and living impurities are removed as a result of filtration. Who are removed? Silt, sand. Okay, clear?
Yes, sir.
So this is very important. Surface water and groundwater. What are the differences? Understand the mechanism. Okay, it's very important. So quality of water in general, if you see that for surface water, physical quality is bad. Why? Because in surface water you will have silt, sand, bacteria, virus. So physical quality is bad, but it does not have iron, manganese. So chemical quality is good, right?
Yes, sir.
In surface water, do you have can you have bacteria, virus? Yes, it's highly likely. So this is that. Now let's talk about groundwater. Physical, do you have silt, sand? No. So this is good. Chemical, do you have iron, manganese, these things? Yes. So this is bad. Can you have bacteria? Most of the bacteria and these things are filtered, if not all. So this is good. Clear?
Yes, sir.
Very important. You know what is potable and palatable? Potable means the water which has three characteristics: physically, chemically, and bacteriologically acceptable. That means you can drink this water. Safe to drink. It is safe to drink, free from disease producing organisms and harmful chemicals, pleasant to taste, free from physical and some chemical impurities, suitable for domestic usage, for cooking, washing, these things. This is potable. Now, what is palatable? Physically acceptable, fine, free from turbidity, color, taste, odor, temperature, but it may not be free from bacteria and virus and other. So palatable means that it looks good. Palatable means it looks good. There is no sand particle. Turbidity means suspended particle. There is no sand particle. There is no extra color. Crystal clear. Taste is good. Odor, no odor. Temperature, moderate temperature. Even after meeting all these criteria, there may be bacteria and virus present in the water, right? So palatable means looks good, physically acceptable, but may not be safe to drink. But potable water means it's safe to drink, safe to drink. So which one do you need, want to drink? Palatable or potable?
Portable.
Potable.
Okay. The water might look good, but may contain virus. That's not potable. Potable is looks good at the same time does not contain any harmful microorganisms or any other substances. Okay. Any questions from here, guys?
No, sir.
Okay.
স্যার আমাদের
Yeah.
গ্রাউন্ড ওয়াটার যে মাঝে মধ্যে যারা পান করে টিউবওয়েলের ওরা তো
Hmm.
কেমিক্যাল, ওগুলো তো কেমিক্যাল ফ্রি না তাহলে?
Okay. Okay. So this iron, manganese, calcium, these are not always bad. Remember, these are not always bad. Okay. You need some of them.
Okay.
I mean, you need them at a certain concentration. If they exceed the concentration, then it's bad for your health. You clear? We'll see.
Yes, sir.
For example, your for iron, your limit is, for example, I tell you, your limit is zero point 0.5 milligram per liter. As long as you have zero point 0.1, 0.3, zero point 0.4, it's okay. But when it's 1 milligram per liter, then it's a problem. Okay?
Okay, sir.
Sometimes you may have arsenic, then it's a problem. Arsenic, arsenic plus 5. then it's a problem. It may be cancer. It is carcinogenic. Carcinogenic means may cause cancer. So that's why in many rural areas you see that arsenic contaminated groundwater, you cannot drink it.
Yes, sir.
Yeah. So what you're telling, yes, sometimes groundwater extraction using tube well and this thing, if this contains arsenic, then you must not take that water. It's simple. Okay. Let's see some parameter, the definition of some parameters. Turbidity. Turbidity is what? Simple, very simple. The turbidity is a measure of presence of suspended solid material. Suspended. Remember, suspended solid material. Which one? Suspended solid material is seed, clay, algae, fungi, fats, oil, waste, organic color material. If they present in water, if they present in water, then we call it turbidity. Higher is their presence, higher is the turbidity. Clear? How do you measure it? If you have turbidity in water, if you have turbidity in water, right? The water will be unclear, right? It will
Yes,
not be
sir.
clear. It's unclear water. How do you measure it? We have a machine that's called turbidimeter in our lab. Turbidimeter. Okay. You give, take some sample from here, shake it well, and take some sample and put it in the machine. Turbidimeter. In turbidimeter, you look from above top. This is your sample, which has turbidity. You have a lamp here where you, for example, you have a lamp here where you pass the light. Now, if you do not have any turbidity, then the light will directly pass you, right?
Yes, sir.
Now, if you have turbidity, then this light will be reflected and it will scatter here and there. Or if you, the light will scatter now. The light will scatter. Now, if you put a sensor here, photos, photosensitive sensor, so that when light falls upon this cell, this electricity generator, it can detect. Okay, this easy. Higher is the turbidity, higher is the reflection, higher will be the detection of the light. So, is it clear?
Yes, sir.
Yes, sir.
Simple. Higher is the turbidity, higher is the silt and sample, silt and clay and other materials, turbid materials. Higher will be the reflection of the light, and higher will be the signal from the sensor. If you do not have any turbidity, then the light will directly pass through. Light will directly pass through, and there will be nothing here. There will be nothing here, so there will be no signal. So from there you can calculate the turbidity. Okay? And the unit of turbidity is NTU. Usually the you measure the unit like the unit of mass is kg. The unit of turbidity is NTU. That's called nephelometric turbidity unit. Nephelometric turbidity unit. These are the most common nowadays. Sometimes previously people use JTU, Jackson turbidity unit, but this is not used right now. So you will use NTU. Nephelometric turbidity unit measures the intensity of light scattered 90 degrees. Scattered 90 degrees. This one 90 degrees. Measure this one. to the path of incidence light. That's it. So this is the lamp. This is the sample. If you have turbidity here, if you don't have turbidity, the light will directly pass through. If you have particles here, it will reflect. And this is the photosensitive cell or photoelectric cell. It can detect. Okay, clear?
Yes,
Yes,
sir.
sir.
Color. Color is another parameter. Of course, if you want to have drinking water and that water has color, you don't want to drink it. Okay. True color is measured by material in solution and should be distinguished from turbidity. You know what? Listen, as I told you, that turbidity comes from where? Turbidity comes from these types of pollutant, which has greater than 1 micrometer, and you can easily filter this out. Now, if you have turbidity in water, if you have turbidity in water, that may also give you color. Am I right?
Yes, sir.
That is, and since this color can easily be filtered out, that's called apparent color. Apparent color. But if you get the color from the dissolved pollutant, which are dissolved, color is called dissolved. Can you filter them out? No, that's true color. If I give you an example, if you have sand and silt, different types of sand and silt, the water will be cloudy, right? It will look like not clear. All right. If you
Yes, sir.
put some
Yes, sir.
silt and sand, and you can filter out, and it's gone. The color is gone. Now, if you make juice without any pulp, for example, anything like any color, if you use a color here, it will get what, yellow or something else. If you filter it out, would the color go away?
No, sir.
No. So that's true color. So there are two types of color. One is true color, and another is apparent color. Apparent color and true color. We're not worried about apparent color. This can easily be filtered out. We are concerned about true color. Okay. So in lab we measure the true color. So it should be distinguished from the turbidity. So apparent color comes from turbidity. Okay. The true color does not come from turbidity. It comes from the dissolved or colloidal material or substances. Odor and taste. By the way, we can also measure color. There's a color meter. Okay, you can also measure the color. True color may be due to the presence of dyes, as I told you, dye, other organic waste, highly colored industrial waste, like the wastewater from the textile industry. If you see the effluent from the textile industry, it's basically black, almost black. It's so dark. Okay, so odor and taste. Of course, if you have pollutant in your water caused by salts and other indistinct other substances, then you may have odor in your water, right? And the taste will also be different. So what are the sources? The sources can be dissolved gas. Sometimes gases can also be in dissolved in water. Gases can also be dissolved in water, like hydrogen sulfide, even oxygen. Very important, oxygen. We call it dissolved oxygen. When oxygen is dissolved in water, we call it, and this is important, dissolved oxygen, DO. We call it DO, dissolved oxygen. If dissolved oxygen is less than DO, is less than 4 milligram per liter, then the aquatic fish, aquatic lives cannot survive. The fish and other uh, uh, aquatic lives, majority of them, not if not all, will die. And that's why in aquarium, what do? You always you sometimes use bubble to air it. You apply air. Applying air means you're applying oxygen, because in air you have oxygen, right? So if you apply air, there will be oxygen, so that the DO is greater than or equal 4 milligram per liter. If it's less than this, the fish will die. Am I clear?
Yes, sir.
Anyway, where were I? I was here. I was here. The dissolved gases. The gas and sometimes and hydrogen sulfide. This is not good. Oxygen we need this. Yeah. DO we need this in water. But hydrogen sulfide, that will have a bad odor from the water. Organic matter, decomposing organic matter, industrial wastes like phenol, chlorine, iron, manganese. They may cause odor and taste in water. Okay. Temperature, the single most parameter in water, which can change the whole game. Very important water quality parameter. Okay. What is specific conductivity? Before I go there, I want to discuss this thing. Total dissolved solid. Total dissolved solids. Water naturally accumulates a variety of dissolved salts and salts as it passes through soils and rocks on its way to sea. What causes salt in water? Saline water. Cations, different types of cations and anions. For example, sodium, ca- calcium ion, magnesium ion, potassium ion, and anions like chloride, sulfate, bicarbonate ion. These are salts in water. If they are in water, the water the water will taste salty. Is it clear?
Yes, sir.
Look at this. This is a solid. Sodium, sodium solid. Calcium, right? Magnesium solid. Potassium. So we call it dissolved. How do you measure this salt? We measure this salt using these solids, right? Using these solids, and they are dissolved in water. They are dissolved in water. And there are different types of solids. So total dissolved solid. What are they? Sodium, potassium, magnesium, and others. So sodium, calcium, potassium, magnesium, can call calcium also is there. So we call it total dissolved solid TDS. What do we measure using this TDS? We measure the salinity of water. How much salt is present in water? Is it clear?
Yes, sir.
Okay. That's it. We'll come to this topic in detail, into more detail again. So TDS, total dissolved solid. In drinking water, usually this TDS is not greater than 300 milligram per liter. Is good 300 to 600 milligram per liter. But when TDS is around, when this TDS is around 1000 milligram per liter, you will test the water as salty. You taste the water salty. For example, in the southern part of Bangladesh, since this is near to the ocean, there are there is salinity intrusion, and in those tube well, if someone have their someone has their home at that area, you know that if you drink water from the groundwater from that area, you'll find it salty, a little bit of salty, am I right? Because TDS is very high, 1000. But when it exceeds 1200 milligram per liter, that is unacceptable to drink. That is unacceptable to drink. Clear?
Yes, sir.
There are laboratory procedure to measure TDS. Okay? There is another procedure to measure TDS. What is the mechanism that if you have these ions in water, if water has these ions, that means if you put a cathode and anode, then this ion makes it easier for the electron to pass. Am I right? So greater is the number of ions, greater is the number of ion, greater is the conductivity of electricity. Am I right?
Yes, sir.
Because ions is there, so they can transfer electrons from cathode to from anode to cathode. So this is called electrical conductivity (EC). So higher is the TDS, higher is the electrical conductivity. Higher is the TDS, higher is the ions, and higher is the electrical conductivity. So there is a relationship between electrical conductivity and TDS, and that is basically TDS equals to 0.552 to 0.6 into electrical conductivity. So TDS can be measured using electrical conductivity. So equals to 0.55 to zero point 0.7. Okay, sometimes it can also be zero point 0.7. So 0.55 to zero point 0.7 multiplied by electrical conductivity, where where the unit of this electrical conductivity has to be microsiemens per centimeter, microsiemens per centimeter, and TDS unit will be milligram per liter. Milligram per liter. Is it clear, guys?
Yes, sir.
Okay, so that's all for today. Next day we will start new topics, inshallah. Do you have any questions?
Sir, I miss the roll call.
In the class, don't talk about roll call. Let's talk about the topics. Do you have any questions about
Sir,
the topic?
distilled water or sir portable water the same.
Look, distilled water is safe to drink. That's okay, but it's not desirable to have drinking water because, as I told you, you need these ions for your body, right? You can say that distilled water is to some extent potable. Sorry, yeah, potable, but you know, drinking distilled water for a long time, that's not desirable. Clear? Because distilled water does not have sodium production, only H2O. But your body needs this sodium production. Is it clear?
Yes, sir.
But the one line answer for your question is yes, distilled water is potable water, but not always desired to drink because it does it lacks the important ions for our body.
Okay, sir.
Any other questions? No. Okay, then thank you very much. Have a good one and stay safe.